Pi is one of the most mysterious numbers in the world. You know, that famous irrational number that starts with 3.14 and goes to infinity. It is so famous that the 14th day of the third month is celebrated as Pi Day in many parts of the world. Happy Pi Day 14th of March! After all, what makes this issue so worthy of celebration? It's also Albert Einstein's birthday. Where does this number appear outside of math lessons at school? Everywhere. Even with the needle you see in my hand, I can show you the number of pi. The relationship between our physical world and mathematics is not just a day on the calendar. First, let's remember where this ratio comes from. This number is the ratio of the circumference of the circle to its diameter. No matter which circle you look at in the world, which one you measure, it never changes. They definitely have this ratio. This is a number very close to 3. But not 3. So you can't take pi 3, smiley face. Even people 4,000 years ago didn't take pi 3. At least they knew one digit after 3 very well. The Egyptians, by their reckoning, pi number 3.1605, could not have built the pyramids had they not known. Last summer, a record was broken. A computer in Switzerland worked 108 days to calculate 62.8 trillion decimal places of pi. One small step for a big, forever number for us. So, do you need to calculate that many digits? After all, even people with the best memory have been able to memorize up to 70,000 digits so far. No, normally this is not necessary. Memorizers do it as a hobby or as a mental exercise. It is also considered as an indicator for computers to prove their computational power. That's why even NASA doesn't bother with the trillions of digits of pi in its calculations. I still left the link of the first 100,000 digits in the explanations section in case it is needed. As a result, you just need to memorize the first 13 digits of pi using the philology method. I showed you how to do it at the beginning of the video. Finally, we will reinforce it again, don't worry. So if you put hundreds of toothpicks or matchsticks on the paper, if we randomly distribute it, the ratio of all overlapping lines will be approximately the number of pi. In 1901, a mathematician named Mario Lazzarini tried this 3,408 times and managed to correctly calculate the 6 decimal digits of the number pi. But as I said, now we have computers. With a code we will write on the computer, we can ensure that these needles are thrown between two lines randomly, not tens or hundreds of times, but thousands of times. As we increase the number of these trials, we are getting closer and closer to the pi number. This method is called Monte Carlo simulation. We can describe it as numerical computational algorithms that are used to obtain a set of numerical results with a large number of repeated random samplings. These methods are widely used in many fields of science. It was used for the first time in Los Alamos Laboratory, where the atomic bomb was developed, to model shields against neutrons scattered after the explosion of the bomb. Today, from cell simulation to stock market models, it is used in many different fields from simulation of natural events such as weather to nuclear physics. Not to mention the ratio of a circle to its diameter. It is already very easy to see it in circular objects around us, but since we can find it even in random drops of the needle, it may be necessary to think a little more about the number of pi. Because it pops up in places you wouldn't expect. Hundreds of formulas have emerged as a result of the work people have done to understand the physical world using the pi number. Yes, all of these formulas use pi. But we cannot expect everyone to understand these formulas in order to appreciate the value of this number. The easiest thing anyone can do is pay attention to the things associated with this number or run them for a few minutes, even once a year. 3. Do this yourself on the 14th day of the month. Take a look around. You are the variable sequence number that comes out with an infinite number when that area is divided by that perimeter. 3. 1415926535897